Okay, I'm gonna try do 43 again. I didn't like the way it turned out in class today. First, let's start with point A just so we can revisit this. To look at point A, we're going to say we want to find out at which point A or point B, do you expect the magnitude of the net magnetic field to be greater? And we'll explain our choice. So we can do this by inspection, and I'll look at it this way. Let's first, I'm going to label this 6.2 amp current. I'm going to label this I1, and I'm going to label 4.5 amps as I2 to get started. So if I look at I1 and I use I1 in the right hand rule, if I point my thumb in the direction of I1, curl the right hand fingers, at the point A, my fingers would be pointing out of the page. So we get, let me draw this, and I'll do this in purple. So for I1, the current is pointing out at point A. And of course at point B, it's pointing in by the same, using the same right hand rule. Thumb up, use the right hand rule. On the side B, my fingers would be curling into the page, so it sort of loops around that conductor. For I2, on the other hand, again, use the right hand rule, point your thumb in the direction of I2, curl your fingers above the wire there on that page. For both locations, the field is coming out of the page. So what we get is we've got two field vectors reinforcing each other at point A, so I'll have a stronger field, or I'll have two competing force or magnetic field vectors going in opposite directions, and it's the vector sum. The total field is the vector sum of those at that point. So no matter what the magnitudes are, the two magnitudes adding together will be a greater value when they're going in the same direction. It'll be a lesser value in the other direction. So um, just by inspection, the field B is stronger. I should say the magnitude of B is stronger at point A, as it is the superposition of both field vector B1 and B2. And they're in the same direction at A and the opposite directions at B. Let's stop it here. I'll save this one up to YouTube, and we'll move on to part B.